Hi, in this video, we will see through the steps involved in making an simple 1D pendulum model using 20sim software. So go to library and look for iconic diagram, mechanical, rotational, components, and you will find a component named as unbalanced. Just drag and drop in the library. Next, we can also drag drop either a friction model or a bearing model. So I drag drop a friction model in CV format, okay, and a gain block. For the gain block, I go to signals, block diagram, and a gain block. I also look for a signal monitor so that I can display the outputs. I start making connections. So friction to the pendulum shaft and the output of this. Okay. Now this unbalanced is not giving an output, so we can open on this, and at the same time I open this and extend this model. So here you can see that unbalanced model has only one port, which is the input. I also need to see its angle of the mass at its output. So I add a port. So right click over here, say add port. Click on output and you can name that port as mass angle. So select this as an output, type real, say OK. Now if double click on the unbalanced code, just write this mass underscore angle is equal to phi. So we will also get the phi output of this mass at its output. Now connect this to gain block and to the signal monitor. Now we can observe this output and see how this angle moves around of the pendulum if the mass is dropped from some particular angle. So I just make sure that I've chosen the right signal monitor. Yes, it's a plot. I call this as mass angle. So here you can see the output is 0. So maybe I just change some configuration. Like in unbalanced, I can specify the length in meters. So start by 200 centimeters, 200 millimeters, and the mass being as something very low value, 50 grams. Okay, maybe okay. Now let's start simulating it. So you don't see any output still coming. That's because we have not specialized, told him the initial angle of it. So the initial angle as 3.14 is a pi. The pi is 360. So I divide by 2. So that is the 90-degree angle I will get in radians. So that is a 90-degree angle. I start from minus 90 and start simulation. Okay, the slope value is very high. The initial value of the friction model is very high, so we have to reduce this. So either we can change here, or in the simulation, before starting simulation, I can open the parameter block. In the friction, instead of 1 Newton meter, this has to be something 100 micro Newton meter, and the slope is okay, 1000, and even the torque applied, that should be very low, maybe 500 micro Newton meter. Now that should be okay. I reset the simulation and redraw. So there you can see that this is how the output comes up of the pendulum. Maybe we can change some values. So this was 5 grams, so I make it something higher value, 30 grams. The length is 200, which is approximately close to our desired length, or maybe 210. I make it. Yeah, so this is how you can see the angular performance of the pendulum mass. So it starts oscillating, and after a while it settles down to a value. Now this value again we see in radians, so we can convert this into degrees by double clicking on this gain block and writing a small equation, because the radians to degree conversion is you just multiply divide the input by pi and multiply by 180. So I just set the value of k as 180, so this default equations can be used. Yeah, so I just check it and start simulating. So here I'm getting 180, so okay, so this has to be made 0, so I just add 180 to it in the equation. Yeah, now we can see that we are getting almost 0 value over here, and the pendulum is swinging between plus minus 90 range. Yeah, you can play with the different parameters like weight, length, and the friction models to see the effect on it. For example, if I change the slope and I just replot, so I don't see any effect on it. But yes, if I change this Coulomb coefficient, definitely I see some effect on it. So the transition time is increased, and if I reduced the friction coefficient maybe 50, so there you can see it goes far away. 90, this is the rotational friction. Yeah, this looks okay now. So this is our pendulum simulation of 1D model. Thank you very much.